My name's Robert Ward. I am I'm a co-founder of the Arch Reactor hackerspace in St. Louis, the company Jurastat Inc., my current employer. Cub Scout leader, Cowgirl bike enthusiast, and I built this cool playhouse for my kids this weekend, which isn't really relevant, but I want to show it off every chance I get. Why am I here? Why are they letting me stand up and talk to you all? I've been here several times and they keep letting me come back, so I must be doing something worthwhile. And currently I'm building quote unquote AI products for the legal industry. Specifically working on an LLM agent for slicing and dicing patent analytics, kind of the bread and butter product my company makes. Analyzing USPTO rejections and offering insights to patent attorneys who are working on products, and offering suggestions based on kind of past performance. So that's the kind of waters I've been swimming in lately that have resulted in what I'm going to talk about here today. First, a confession before I start talking about this. I am an AI skeptic. I don't really believe that large language models are going to lead to superhuman intelligence or replace all people or any of that nonsense. I'm not even really particularly impressed with a lot of the stuff we're seeing today for most use cases. I really hate every time Google takes up the top third of my screen with a bunch of nonsense where every time I know what I'm talking about, I can tell it's bullshit, which makes me not trust it the rest of the time, obviously. So a promise I will make here today, this is all my work. I have not put anything into ChatGPT. I am not reading what Claude is telling me to do. No AI at all was used in either the content or the demos you're going to see. It was all typed out by my own 10 little fingers. So my AI story, I've given you kind of a heads up of what I tend to think about a lot of the AI stuff that works out there. I've been disappointed with AI search. I think I spoke to that. Disappointed with the AI assistants. I think we've all played around with Siri and the Google Assistant and all that stuff. And it's great when I'm setting a kitchen timer to tell me when my brownies are finished cooking, but for anything serious, they're crap. But I've been really happy with transcription and kind of transforming data from one thing into another. Kind of the first time I ever really had there's something useful here was when I used, I put a shopping list into Claude and then had it start listening to me talk, and I went through and listed all the things that I saw in my fridge, and it crossed off everything on the list that I already had and gave me the shopping list of just the things I needed to go get. And I was like, oh, that's actually helpful, because now I don't have to have my hands full with my phone while I'm typing the stuff. I can actually just look, think about what I need, and then let this thing take care of it for me. Similarly, at work, I think like a lot of places, we have executives from on high saying, hey, we need to get on this AI stuff. We need to start doing it. It's going to make everything better. So, we've been pressured to kind of play around with it to see what we can make it do. Haven't been super impressed with the coding tools. I know a lot of other people have. I haven't seen it yet. Especially disappointed with writing tools. I think we've all now pretty quickly come to recognize the kind of tenor and the sound of AI writing, and it's obvious, and it makes me so mad every time I get on a blog post or a Reddit post and I see some nonsense that's clearly been spit out of ChatGPT. If you're not going to take the time to write it, why am I taking the time to read it? But I've been really happy with it for data extraction. So I work a lot with patent data, so I'm working with the USPTO a lot. The USPTO's data access is, if not the worst of any government agency, it's got to be up there. If you send the USPTO the claims for your patent in a docx file, they will print that docx file to a PDF, strip the text layer out of it, and that's how they store it. It's literally a picture. of your claims. So then when we want to go get that data out, do a data analysis on it, we then have to re-OCR the PDF, pull the data out of it, try to build some structure around it, and then we can start working with it. So I've been doing this for 10 years now. We've got a large suite of tools for doing that kind of data extraction, with very complicated regular expressions and programs that kind of look for lines to pull data out of boxes and that kind of thing. But AI tools have actually been really great at improving a lot of that data extraction, even above and beyond what we've already done. So the common thread of kind of that use case of kind of translating the thing I'm reading out loud, turning unstructured documents into structured data, is that large language models aren't good at creating things, but I think they're great at translating. I think they're great at converting meaning from one form into another. And so that's where I've been focusing a lot of my work lately. So that brings me to tool calling, what we're talking about tonight. So this is let me just say, I'm guessing most people use ChatGPT, Claude, things like that. And people played around with the integrations where you can like hook up your Google Drive or Model Context Protocol servers. Anyone played around with stuff like that? A little bit? Okay. So tool calling's kind of a hot buzzword. You'll hear it called different things. MCP servers, that's Anthropic's big push that they've been working on. Retrieval augmented generation, you'll hear that. Perplexity and some of these other companies have been working with things like that. Tool calling, basic name. Function calling, OpenAI's term for it. Or just integrations, you'll hear, which is, we'll integrate ChatGPT with your email or whatever. So these are all just kind of buzzwords for the same thing. Fundamentally, it's all the same technology, and that's structured output. So when you're normally interacting with an LLM, you get unstructured output. You get just common language. So what's the capital of Austria? Capital city of Austria is Vienna. Unstructured output, language in, language out. Structured output is where you have a more complex language model that can actually give you data in a format, machine-readable format that you can expect. So what's the capital of Austria? Structured output would be country, Austria capital, Vienna, nice JSON blob. We could parse that into a data structure and do something interesting with it. So most of this talk is just going to be me taking you through some demos of kind of structured output tool calling stuff that I've been playing around with to show you some basic techniques that I have found really useful. I'll make time for questions at the end, but just raise your hand if you want me to go through any of the stuff. I'm going to pull up some code and scroll through it. Like I said, it's all there in the links, but if you want to ask some clarifying questions, just jump in. The first one, the simplest, is that readable? No, it's not really, is it? Let me go to, so this is my yes-no demo. Let me go. The goal of this demo was you take a human answer and convert it into a yes, no, or a maybe answer. So if you're just trying to get a confirmation from the user, if you're trying to turn an answer of someone saying, yeah, I guess, into a Boolean yes, you can use an LLM to do that. Really simple use case. You can see I've got yes, no, absolutely, no way, man, I'm not sure, comes back as a maybe, and definitely will come back as a yes. So you see we've translated the lots of different ways that a person will answer affirmatively into a binary yes, no that a machine can consume. Let me go through the code for that. So the most important kind of part of the structured output is being able to define your structure. If you're not familiar with Zod, it's a way to create structured JSON schemas for JavaScript and TypeScript. So in this case, I'm saying I want an object with answer, and answer needs to be yes, maybe, or no. And I'm telling the large language model that whatever input you get, this is the only output I want. So we pass that in, we give a system prompt that explains to the LLM what its job is supposed to be here, and then we pass in the request from the user. We tell it we want the output down here, it's a JSON schema, yes, no schema, this thing we've defined up here, and then we pass it in. And so now, for a large language model that supports structured output, you pass that in and you're going to get, most of the time, sometimes not, but most of the time, you're going to get something that matches that output. This isn't, this was, I thought, kind of a little fun use case for that. I wrote a little 20 questions game that it'll play with you. It's not really related to the tool calling. I just thought it was a fun use case for the yes/no answer. It'll play 20 questions at the end. It's pretty good. I played a bunch of games of it while I was writing this. Document parsing. So this is kind of what led to me wanting to do this talk, is figuring out how to process documents, really just images, into structured data. Same kind of thing. First one here is signature extraction. So one of the things we often have to do is figure out what is the actual attorney who signed this document. A lot of times in my work, we'll have a single case that a bunch of different attorneys work on. We actually want to be able to assign responsibility for someone saying, you know, this is the specific person that drafted these claims. Just like engineers, lawyers will constantly throw the last guy who worked on the case under the bus. So, you know, if these claims get rejected, oh, well, those were written by Steve, he's an idiot. And they really hate it when you attribute something to them that they didn't do. So it's important for us to be able to extract actual signature data. Same kind of thing, structure here. We're saying we want the name and the registration number of whoever signed the document. And then instead of passing in the content as text, obviously you pass it in as a PDF file. Show you the. So this is the signature block that we're actually wanting the system to look for. This is on page 5 of 7, and it's towards the middle. It's not real obvious where it is, but the only hints we gave to that system were, you need to look for signatures. That's the entirety of the instructions we had to give it. You need to look for signatures. We pass it a 7-page PDF document, and we get back you can see here from that previous document, it correctly parses both the name and the registration number with just that minimal input. Cost for that for a 7-page PDF document is about half a penny with Gemini Flash, which is at the scale we work at is not affordable to do for everything, but when you really need the right answer, it's actually better than the regular expression systems we've built in the past. Another document parsing that I think was really interesting. This is a personal project. I've got a bunch of scanned old documents and bills and stuff like that in my archive at home. Want to categorize them. Want to figure out what's what. Find duplicate bills. We've had a lot of random medical bills this year, and we've paid some people twice and want to kind of figure out all our records and stuff. So scan a bill in, and we ask just a couple of standard questions. So in this case, I want to know who's the bill from, account number, due date, and amount due. And again, just like the last one, we tell it its job is to extract information from the thing. We give it the structure, just here's the things we want, and then pass the image in, and it gives us back nice structured data we can import into a database, anything else. Personal assistant. Okay, so this demonstrates. This is kind of a technique that I've developed. Oh yeah.
As AI loves to do, it hallucinates. I do something very similar on my day-to-day for work, and I haven't quite been able to, when I'm working with like really specific types of data, not get it to sometimes throw in a little bit of a hallucination. Did you ever experience that with what you're doing?
I had.
And follow-up, because you mentioned it when you were talking about the yes and no data.
Yeah.
Do you have any idea on what the error rate is for what she's talking about?
So I can tell you, because we have a very large test set for some of this. In my experience, reducing those hallucinations is all about keeping your context as small as possible.
Okay.
So I would never feed in a 7-page document to extract the signature. I would figure out which page the signature document was on. I would, if it's a standard form where I know what part of the page it is, I would cut that part out. So I would just feed in the specific place that I know. And in those cases, it's more reliable than our existing data processing. So, the error rate there is acceptable to us. But I mean, well over 3 nines.
Okay.
Less than 1 in 100. And the errors we do get are mostly OCRing errors. Where it's flipped a 1 to a 7 in the registration number, that kind of thing. Made up data we haven't really seen, but again, it is about focusing that context down as small as you possibly can using every other technique before you bring in the LLM. And that's kind of what I was going to talk about here with kind of the personal assistant things I've been playing around with. So you want to give the actual LLM as small of a job as you possibly can, and just get that specific piece of information you want out of it. So personal assistant toy I've been playing around with, some home automation stuff and everything. I kind of have a 3-phase approach to this that I've been working with. Same kind of stuff with the document parsing, but applied somewhere differently. And that's, you decide the intent, you find the target, and then you actually perform the action. So the way this kind of personal assistant thing works is you get the user input and it says, is this a request for information or a request for action? High-level categorization, binary, yes or no choice, very reliable. If it's an action, okay, then it decides the action. Now, with 6 possible options, you would be able to feed all those things into an LLM at once and probably have even a smaller model handle them. But if you have, at the bottom of this tree, 300 different actions, feeding all of that tool calling context into it is you're going to get a lot more hallucinations and a lot more wrong stuff. And so by kind of taking a phased approach where we make one call for categorization, another call for here, and then make a third call to actually perform the action where we say, this user is asking you to set a timer, please return the timer content that we need. You're going to get good data out of that because you're not asking it 50 different questions. You're asking it one focused question that you've determined is what's going on. So you can kind of see a demo here. What's the weather like in Nashville? Well, it knows, okay, that's it, a request for information. They're asking for the weather. And then we say, okay, go get answer the question the user is making using the weather here. The code for this, a little more complicated, just because it's multiple phases. So we have a categorize request. You're part of a series of agents. Categorize a request at a high level, and then we return back out, the specific category, if it's information or if it's a request for an action. Then we come down here and we say, okay, handle an information request, which it gets, again, multiple tools. It knows which one to handle. And then I ran out of time, so these were all just kind of stubbed out, but you get the idea. Setting a timer would be the same kind of thing we've done before. Okay, how long does a user want to set a timer for? You can extract that information and then perform your tool call. Okay, so we talked about structured output. All of this was one way. It was information. You put in a prompt and you get back out structured data. But tool calling is about closing that loop, allowing the LLM to actually request information and get further data into the context. So the kind of loop for this is you have user input, an LLM call, and then the LLM may say, I want to call a tool to process this request, in which case you handle the tool call, go back here. That can happen multiple times. It could, if you ask, the demo I'm going to show you is about getting the weather again. If you say, hey, do I need a jacket for my trip to Nashville this weekend? It might request the weather currently. It might request historical weather. It might request what is the forecast for this weekend. Make multiple calls to get multiple bits of information. When it has all that information in its context window, it can then return a message to the user. So here's that exact demo. Do I need to wear a jacket for my trip to Nashville this weekend? It's making a tool call to get for city, city, state, country, gives back, and then it returns a whole thing that says, yeah, you probably want to bring a jacket. Let's see there. So all of that, it parses the weather information and gives you kind of useful input. So here's the code for that. I'm going to skip over that stuff. Okay. Important part of actually implementing a tool calling agent, LLM, whatever you want to call it, we're going to loop through the same loop until the LLM actually tells us it has output for the user. So we make a call with the current message queue so far. When this starts out, it's just going to be the message that the user has actually prompted us for. Then we're going to handle any tool calls that come across. So in this case, we only have one tool, two tools, one for get the current weather, one for getting the forecast. Some LLMs will make multiple tool calls at once. Some will make one tool call and then make another one and then make another one. You kind of have to be ready for anything. So in this case, we handle our tool call, gets the weather. This will return a message that's formatted to get put back onto the message queue. So after we get back our tool call messages, we put them on the message queue and send it back up to call the LLM again. And we keep doing that until it stops calling tools, and we assume at that point, okay, you've got information that you want to return to the user. And then we do. So there's a handful of tool calling formats that have kind of emerged. There's OpenAI, which is what all of the demos here were written in the OpenAPI tool calling format, but using OpenRouter. OpenRouter, if you're not familiar, is basically a system that lets you, through a single API, call basically any LLM system out there. Really handy if you want to play around with a bunch of them. Bedrock, that's AWS's common API, same kind of thing, but it's through AWS. You can call a bunch of different LLMs through a single format. And then there's the MCP, Model Context Protocol, that's Anthropic's remote tool calling framework. So you can have an MCP server hosted on the internet, you can point your LLM at it, and the idea is there's a standard format where you can expose an API meant to be consumed by large language models. They all pretty much do exactly the same thing. There's three kind of pieces of information. There's the tool name, obviously, get weather, set a timer, write a note, that kind of thing. A tool arguments, that structured data output that we want to pass to the tool, translating that human request into a machine request. And then a tool use ID, so that when they're restructuring the context window to go into that LLM, they can put the request and the response right next to each other, make it easier for the system to kind of get useful data out of it. I'll go through a couple of these. This is the OpenAI API. They have the function calling, which is what they call their tool calling. They also now have what they call custom tools, which are where your structured output isn't just a JSON schema, but it can be any context-free grammar. I don't really understand the use case, and I spent a bunch of time reading about it because I wanted to include it here, but I don't get what they're going for. Your tool names, and then the output schema. Descriptions are really important for these. Obviously, that's, just like if you're trying to write good docs for human developers, you're writing docs for a particularly dim junior developer who's going to be calling your API here. So handling tool call, same kind of thing. We return in, this is kind of an important difference. In OpenAI has a dedicated role just for tools. With Bedrock and MCP servers, the role in the back and forth conversation for tools is the user. As far as the LLM system is concerned, in most systems, that tool call comes from the user, but OpenAI actually has a separate role. I assume they're doing something different with it on the back end. The specific ID and then the content. Content can be a little weird when you're returning data to large language models. I have had a lot of success with Markdown, even complex Markdown, like putting tables and things like that. They seem to handle well. You can also just pass JSON back to it. You can pass XML or HTML if you want, but in my experience, Markdown's kind of the best way to go. Bedrock, same kind of thing. We have your tool name, your tool description, and JSON schema, exact same, pretty much. Little bit of different in how you return it. I called out that the role for Bedrock is your user. They don't have a tool role in the conversation, and then your content has to be kind of wrapped differently. Model context protocol. I think this is probably the most interesting thing happening with tool calling because, again, it is a standard framework. It's designed to be used remotely over the internet. It is pretty trivial to translate MCP tools into tool calls for either OpenAI or Bedrock. Just a few lines of code to move some things around in your JSON objects. Really, really easy to get started with making an MCP server if you want to with their toolkit. So this is exposing a tool that you're giving it a name. I'm sorry, the contrast is a little crappy. You give it a name, you give it a description, you give it a data schema, and a handler. And these are meant to be run remotely. They're meant to be run on one server talking over the internet. Handling the tool call, same kind of thing. You get your arguments from a tool call, do your remote MCP call, and return the result. Sorry, I mentioned I built a playhouse. I do have kids at home, and they have gotten me ruthlessly sick right before I have to come give a talk. Some inspiration. These are all projects I have in the past worked on or am working on using tool calling at work or at home. Plating tool. I think this was a pretty big breakthrough as I've been trying to do AI agent stuff. Of you ask the LLM to make a plan and return it to you as an array of prompts that you're going to call on itself. And you can get really, really complex results out of even lower grade large language models by just saying, hey, make a plan first, and then calling each of those plan steps individually, feeding the result back in once it's done. Home automation, I mentioned that. I'm a big Home Assistant guy, so at home I've been working on a custom system for Alexa, that type of stuff. Not having a whole lot of luck with that because I'm not willing to use any cloud-hosted LLM stuff, and I don't have enough graphics cards at home to do anything real big. But I'm hoping that'll change. Personal knowledge base. This one's really interesting. If you have a bunch of notes at home, if you have a bunch of handwritten note pages scanned into something, you can get really interesting insights out of having things scanned and categorized, automatically tagged, that sort of stuff by models. And then custom assistant. I mentioned that, kind of showed off. Same kind of thing as the home automation, but more general. And document organization. That's been a big one for me. That's what I do at work, is a lot of document organization and parsing. Incredibly useful for that. And that's it. That's what I had. I rushed through it a little bit. So any questions? All right. Thank you all.